Assalamu alaikum. In this lecture, we are going to find the potential difference between the 2 points due to a charge. So we are going to start from a charge which is having a value of plus q. So we have a positive charge, and then there are 2 points p1 and p2 that are away from from that positive charge. So p1 is closer to the charge and p2 is a little bit further away from the charge plus q. So if we assume that we have another positive charge and we have to bring it towards the conductor or the positive q charge, then what we have to do, we have to do some work done in moving the charge from p2 to p1. And now if we have to move this positive charge away from the conductor, or if we have to move this charge from p1 to p2, then what we have to do, we have to actually release the energy. That plus q charge will be releasing some sort of energy. So in case of movement from p2 to p1, there is some work done required in moving the charge, and if we have to move the charge from p1 to p2, then the energy will be released. So this p1 point or this equipotential surface is at higher potential, in comparison to this equipotential surface which is at lower potential. So there is a potential difference between these 2 points p1 and p2. So what is the potential difference? It is actually the work done in moving a unit charge through an electric field that is being produced by a charge on a conductor. So in order to calculate that work done or the potential difference between these 2 points, what you have to do, you have to actually integrate the electric field intensity over the radial path between the two equipotential surfaces. So what you have to do, you have to actually integrate the electric field intensity over the radial path. Between the equipotential surfaces. So this will be the equation. If you have to find the potential difference between 2 points, point 1 and 2, you have to integrate the electric field intensity dx between these 2 points d1 to d2. This is actually the distance. d1 and d2 are the distances from p1 and p2 respectively. So when I am calculating this, we know that this E value is q over 2 pi kx, where k is the permittivity value and k is equal to k naught into kr, and usually kr is taken as 1, so k is equal to k naught. So it can be replaced with k naught. Relative permittivity can be taken as 1. So we know that q, 2 pi k, all of these are the constant values, so it can be taken out of the integral, and the value of integral d1 d2 1 over x dx is actually equal to ln x d1 d2. So it will be ln d2 minus d1 and ln d1 d2 over d1. So this is the final formula for the voltage difference or potential difference between 2 points v1 2. So if we have a closer look at this voltage value v12, that is q over 2 pi k ln d2 over d1, there is one thing to remember. This point 1 is actually at higher potential and this point 2 is actually at lower potential. And in this formula, this d2 is actually the distance from the charge till point 2, which is the low potential point. So in numerator we have low potential distance, and in denominator we have the high potential distance. So when you are going to use this formula for the calculation of capacitance in 3-phase lines, you have to remember that V12, in case of V12, the point 1 is actually at high potential and the point 2 is at low potential. But in the logarithmic term, in numerator we have the low potential distance, and in denominator we have the high potential distance. Thank you.